Hi everyone. In this video, we are going to discuss about how to find the equation of a straight line that passes through a given point and inclined at a particular angle with two given lines. Now in the diagram, I have the two given lines. Let's suppose we have line A, whose equation is A sub 1 times x plus B sub 1 times y plus C sub 1 equals 0, and line B, whose equation is A sub 2 times x plus B sub 2 times y plus C sub 2 equals 0. And of course, they are not parallel to each other. Those two lines are intersecting lines, right? So now, how many lines can we draw that will be passing through a given point? The point may be somewhere on this plane. And also the line will make equal angles with the two given lines, which are A and B. So now we are talking about a third line which will make equal angles with the line A and line B. So let's try to draw one of those lines first. Here I have drawn a line in pink color, and this line is making theta angle with line A as well as line B. Or if you think about the obtuse angle, that would be the beta angle with line A as well as line B. Can we draw any other line that will also satisfy our requirement that the line will make equal angles with these two given lines? Well, let's try to draw another line and see how that looks. Here I have drawn two other lines in light green color, and they are essentially parallel to the pink line. And if you think about it, each of those green lines also making equal angle or inclined at the same angle with the two given lines. While the pink line was inclined at theta angle with the two given lines, now each of the green lines also inclined at theta angle with the two given lines. So looks like we can have infinite number of lines like this which are parallel to each other, and they could make same angle with the two given lines. And then of course, if we are provided that the line also needs to pass through a given point, let's say the point is x sub 1 comma y sub 1, meaning the point has a coordinate of x sub 1 comma y sub 1. And if we have to draw a line which will be inclined at theta angle with each of the two given lines, and also the line is passing through the point P, then it will be one of those infinite number of lines that we could draw which will satisfy our criteria. Alright, now apart from this type of lines, can we draw any other type of lines that will also satisfy the requirement? Well, let's have a look. Here I have drawn another diagram on the right hand side, and there you can see that we can also draw another line which is in the yellow color, and that line is also inclined at equal angles with the two given lines. Now, is that the only other line we can draw? Well, if we can draw a bunch of lines parallel to this yellow line, they will also be inclined at the equal angle with the two given lines, kind of like this. Each of those yellow lines, they are parallel to each other, and each of the yellow lines is inclined at the same angle with the two given blue lines, right? So looks like we have two types of lines which can be drawn that will be inclined at the same angle with two given lines. Now, what angle it has to be inclined at? That's not the requirement. The requirement is that whatever angle that is, whatever is possible, the new line has to be inclined equally with the two given lines, right? Now, if you think about the pink line and the yellow line that go through the intersection of the two given lines, they will actually be perpendicular to each other, and they are nothing but the angle bisectors between the two given lines, meaning they will bisect the angle between the two given lines. Now, why are they going to be perpendicular? I mean, why the angle bisectors are perpendicular to each other? Let's try to prove that quickly. Here I have drawn another diagram on the bottom left hand side. I have the pink line and the yellow line. Pink line is also inclined at equal angles with the two given lines which are in white color, and also the yellow line is inclined at equal angle with the two given white lines. Now here what we are going to check is that the pink line and the yellow line, they are perpendicular to each other. How can we prove that? Well, if you think about it, on one side of the yellow line, let's take the right hand side maybe, right? So on the right hand side of the yellow line, at the intersection of the two given lines, we have four angles there, right? Now what are those angles? Let me make a quick note here. We have an alpha plus we have a theta, then we have another theta, and we have another alpha that is equal to one straight angle which is 180 degree. And from here we can write it as 2 times alpha plus 2 times theta is equal to 180 degree. and from here we can say that 2 times alpha plus theta is equal to 180 degree, and from here we can easily say that alpha plus theta is equal to 180 degree divided by 2, that is equal to 90 degree. So what is alpha plus theta? Well, that is actually the angle between the pink line and the yellow line. So we can clearly see that the two lines that we can draw to meet our requirement and passing through the intersection of the two given lines, the two new lines are actually perpendicular to each other. And in this case, you can clearly see that the pink line is acting as an angle bisector. Now, which angle is it bisecting? Well, it is bisecting the angle between the two given lines. And similarly, the yellow line is also working as another angle bisector. It is bisecting the angle between the two given lines. It's bisecting the other angle. So the pink line is bisecting, let's say, the obtuse angle, whereas the yellow line is bisecting the acute angle. I hope it is clear up to this point. Now we have to find the equation of these lines, right? The pink line and the yellow line and all the lines that are parallel to the pink line and all the lines that are parallel to the yellow line. But also we have one additional requirement, that the line has to pass through a given point, and we assume that the point's coordinates were x sub 1, y sub 1. So for us to be able to figure out the equation of the new line, we have been given a point which is x sub 1, y sub 1, but also we are going to need the slope of the line so that we can use the point slope form of the equation of a straight line to come up with the equation of this new line, right? We have been given the coordinates of the point, that's helpful, but how are you going to find the slope of this new line? Well, that is the main part of the discussion here. So let's see how we can find out the slope of our new line. Let's assume that the slope of the given line A is m sub 1. I'm making a quick note here. I have noted in red color that the slope of the line A can be assumed as m sub 1 and the slope of the line B can be assumed as m sub 2. Because we have been given the equation of those two lines, we can easily calculate their slope. Now what would be the slope there? Well, if we convert each of the given equations into the slope intercept form, then we can easily find that this slope would be m sub 1 would be equal to negative a sub 1 over b sub 1. And m sub 2 will be equal to negative a sub 2 over b sub 2. Now why is that? Well, let's take one of the equations. Suppose we are taking the first equation, which is a sub 1 times x plus b sub 1 times y plus c sub 1 equals 0. And from here we can say b sub 1 times y is equal to negative of a sub 1 times x and minus c sub 1, and from here if we divide both sides by b sub 1, we get y equals negative a sub 1 over b sub 1 times x, of course, and minus c sub 1 over b sub 1, and this is in y equals mx plus b form, and clearly this is the slope right here. So this is the slope. And similarly, if we convert the second equation, I mean the equation of the second given straight line, from there we'll find that the slope of that line will also be negative a sub 2 over b sub 2. Alright, now we know why the slope of each of the given lines turns out to be like that. So now let's get into the real derivation of the slope of our new line, the pink line. So we are now going to focus on how to calculate the slope of the pink line. Let's assume that the slope of the pink line is m. So I'm making a note right here, just next to the pink line, I'm making a note right here. I'm saying that let's assume the slope of this line is m. So now we have the given lines, the line A, line B, and our new line. We have their slopes, and also we know the angle between each pair of these lines, right? So now let's focus on the new line and line A, for example, right? Now what is the angle between these two lines? Well, the angle is of course theta. We are going to do the derivation based on the angle theta. So let's assume that the angle between them is theta. So what would be tan theta then? Well, in this case we can say tan theta will be equal to m minus m sub 1 over 1 plus m times m sub 1. I have already created another video where we have derived the angle between two intersecting lines, and in that video you will see that the angle was tangent inverse of m minus m sub 1 over 1 plus m times m sub 1. So here all I have changed is that I am writing it as tangent of theta, which is equal to m minus m sub 1 over 1 plus m times m sub 1. I have shared the link of that video in the description. Feel free to watch that video. So for the theta angle between the given line A and our new line in pink color, we can say that tangent of theta is equal to m minus m sub 1 over 1 plus m times m sub 1. And similarly, for the theta angle between the given line B and our new line, can we say that tangent of theta would be equal to m sub 2 minus m over 1 plus m sub 2 times m? And from here we can easily create an equation, and our equation is going to be like this, which is m minus m sub 1 over 1 plus m times m sub 1, that is definitely equal to the value of the tangent of theta in the other form, which is m sub 2 minus m over 1 plus m sub 2 times m. And from this equation, we should be able to calculate the value of m. Now let's try to see how this equation going to look like. If we cross multiply, then what we are going to get on the left hand side? Well, our left hand side will be m minus m sub 1 times 1 plus m sub 2 times m. So I have the numerator of the left hand side and the denominator of the right hand side multiplied together. That is definitely equal to numerator of the right hand side, which is m sub 2 minus m, times 1 plus m times m sub 1. Now let's remove the parenthesis and let's expand it. So from here can we say that m plus m squared times m sub 2 and then minus m sub 1 and then minus m times m sub 1 times m sub 2. That is the expansion on the left hand side. And then on the right hand side, what do we get? Well, on the right hand side, let's write it like this. We get m sub 2 plus m times m sub 1 times m sub 2 minus m and then minus m squared times m sub 1. And if we bring everything to the left hand side, we're going to get something like this. First, I'm trying to focus on the m squared terms, right? So we have one m squared term right here and another m squared term right there. And if we bring the right hand side term to the left hand side, then we're going to have a m squared times m sub 2 and plus m squared times m sub 1. So I'm going to write it as m squared as a common factor times m sub 1 plus m sub 2. Alright, so we took care of the m squared terms. Now how many m terms we have? Well, let's take a look. We have an m term right here on the left hand side. We have another m term on the left hand side right here. And then we have an m term here on the right hand side and another m term on the right hand side. So let's bring everything to the left hand side. So we are going to get a positive m that is on the left hand side already, and the right hand side negative m coming to the left hand side will become positive m again, so it will be 2 times positive m. And then on the left hand side we already have one negative term, which is m times m sub 1 times m sub 2, and on the right hand side we have a positive of the similar term m times m sub 1 times m sub 2. If we bring that to the left hand side, we are going to get 2 of those negative terms. So then this is actually 2 times m times m sub 1 times m sub 2. Alright, we took care of all of those, and now we are left with the m sub 1 and the m sub 2, which are the constants. I mean, those are the given numbers, right? We already know their values from the given equation of the straight lines. So let me write them down here. So it would be negative m sub 1, which is actually this one, and here is another one, which is the m sub 2. So when he comes to the left hand side, he will also become negative, so it will be negative m sub 2, and all of this is equal to 0. And from here, let's rewrite this as m sub 1 plus m sub 2 times m squared, and then let's take m as a common factor out. So we are going to be left with 2 minus 2 times m sub 1 times m sub 2 times m, and then we have a minus. We can write them as m sub 1 plus m sub 2, and all of this is equal to 0. So now you can see that this is a quadratic equation for m. If we consider m as our variable here, then we have a quadratic equation in m. So what would be the value of m? We can use the quadratic formula here. We know the quadratic formula is kind of like this. If the equation is like this, let's say we have ax squared plus bx plus c equals 0. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. You will see where we get the value of x from, right? Now in our equation here, the variable is not x, it is actually m. And if you think about it here, what is a? Well, a is actually this quantity right here. This is our a. That's the coefficient of m squared. And then what is b? Well, b is actually this quantity right here. That's the coefficient of m. And and then what is the constant term c? Well, the constant term c is kind of like this, right? So now let's plug in the values there. So for our equation, we can write the value of m like this. It would be negative b. In our case, what is b? Well, b is actually 2 minus 2 times m sub 1 times m sub 2. So if we say negative b, that would be negative 2 minus 2 times m sub 1 times m sub 2. That is our b. And then plus or minus square root of b squared. So 2 minus 2 times m sub 1 times m sub 2 whole squared. That is our b squared. Minus 4 times a. What is a? Well, a is actually m sub 1 plus m sub 2. And what is c? c is actually negative of m sub 1 plus m sub 2. And all of that over 2 times a, well, that would be 2 times m sub 1 plus m sub 2, that is our a. So from here we have found the value of m, which is the slope of our new line, right? Now if you are thinking, hey, do we really have to remember this ugly looking formula here? Well, actually not. Why? I'm going to show you through an example. We really don't have to remember this formula. However, I wanted to show you how to derive, so that someday if we have to derive something like this, you should be able to do it. So here you can clearly see that we are getting two values of m. Now why are we getting two values? Well, one would be with the plus sign here before the square root, and another value will be with the minus sign before the square root, and two values because we have the pink line and the yellow line which are perpendicular to each other. So we are going to get two different slopes. One slope will be for the pink line or any line parallel to the pink line, and the other slope will be for the yellow line or any lines parallel to the yellow line. And when you take an example, we'll see how that works out. And now that we have found the slope of the line and we have been given a point which was P, let me make a note here again. So the point was P, whose coordinates were x sub 1 comma y sub 1. So our new line has to pass through this point and its slope would be m. So using the point slope form of equation of straight line, we can say that then the equation of our straight line would be something like this. Y minus y sub 1 is equal to m times x minus x sub 1. Now let's take an example and see how to solve this type of problem. Let's suppose we have been given the equations of the two straight lines like this, and we have to find the equations of the straight lines which would be inclined equally to these two given lines, and also they would pass through a point like this. Let's suppose we have a point, let's say 1, 2. So if the straight lines have to pass through 1, 2 and also will be equally inclined to these two given straight lines, then we have to find out the equation of the straight lines, right? So the first thing we need to do is we need to find the value of m, which is the slope of our new straight lines. Now instead of using this formula, I'm going to use our original formula up there. So let me scroll up there a little bit and see what we had. So in this yellow box that you see up there, that is the original equation there, m minus m sub 1 over 1 plus m times m sub 1 is equal to m sub 2 minus m over 1 plus m sub 2 times m. So if we use that equation, then solving our problem would be really easy. So let's try that. So from the first equation, let's try to find out the slope of the first equation. So can we convert this equation? So we have x minus y plus 5 is equal to 0. I'm now going to convert it into y equals mx plus b form. So from here, can we write it like this? We can say that y equals x plus 5, and clearly you can see the coefficient of x is positive 1. So our slope here, if we write it like this, we can say m sub 1, which is the slope of the first given straight line, is equal to positive 1. Alright, similarly let's try to find the slope of the second given line. We have 7 times x minus y minus 3 equals 0, and from here we can say that y equals 7 times x minus 3, and you can clearly see that the coefficient of x is positive 7. So in this case we can say that the slope of this straight line is actually, let's assume it is m sub 2, so that will be equal to positive 7. So we have found the values of m sub 1 and m sub 2. Now calculating the value of m is pretty easy. We are going to use the same equation that we saw up there, and that is m minus m sub 1 over 1 plus m times m sub 1 is equal to m sub sub 2 minus m over 1 plus m sub 2 times m. Now let's plug in the values here. So from here we can say that m minus m sub 1 is actually 1. So we can say m minus 1 over 1 plus m times 1 is equal to m sub 2, that is 7, minus m over 1 plus 7 times m. And if we cross multiply, what we get? Well, we're going to get something like this. It would be m minus 1 times 1 plus 7m, 7 times m, is equal to 7 minus m times 1 plus m. And if we expand them, if we remove the parenthesis, what we get? We get on the left hand side, we get m plus 7 times m squared minus 1 minus 7 times m, and on the right hand side we are going to get 7 plus 7 times m and then minus m and minus m squared. And from here let's bring everything to the left hand side. So on the left hand side we have m plus 7 times m squared minus 1 minus 7 times m, and then the positive 7 from the right hand side will become negative 7, and then the next term positive 7m, that will become negative 7m, negative m will become positive m, and negative m squared will become positive m squared. All of that will be equal to 0. And if we simplify this little bit, let's gather the m squared terms first. So we have 7m squared and one more m squared, that is 8m squared. And then let's collect the m terms. So if we look at the m terms, here we have one positive m and 7 of the negative m's and another 7 of the negative m's and a positive m. So we have 2 positive m's and 14 of the negative m, so that would give us negative 12 times m. And then let's look at the constant terms that we have. We have negative 1 and negative 7, so that is equal to negative 8, and all of that is equal to 0. And from here, if we divide both sides by 4, then we get 2 times m squared minus 3 times m, and then minus 2 is equal to 0. And if we factorize the left hand side, we can easily factorize them. We don't have to use the quadratic formula, we can factorize them. If we cannot factor it, then of course we have to use the quadratic formula, but in this case I think we can easily factorize it. So let's do it like this: 2 times m squared minus 4 times m plus m. So I'm writing the negative 3 times m as negative 4 times m and a positive m, and minus 2 is equal to 0. And from here we can say that 2 times m is a common factor, so that would be m minus 2, and then plus 1 as a common factor, that would be m minus 2. All of this is equal to 0. And from here we can say, well, then our common factor is m minus 2 and the remaining factors are 2 times m plus 1. All of this is equal to 0. And from here we can say, well, then either m minus 2 is equal to 0 or 2 times m plus 1 is equal to 0. And from here we can say, well, then definitely m is equal to positive 2 or m is equal to negative 1/2. So that would be negative 1/2. So we have found two values of m and we have to come up with the two equations. That's pretty easy because we have also been given the coordinates of the point P, and that is 1, 2. You can see up there. So the straight line has to go through that point. So we have the slope, we have a point. Now I'm going to use the point slope form of equation of straight line to come up with the equations of our new straight line. So then the first equation will be like this: y minus y sub 1. Well, the point was like this. Let me make a quick note on the left hand side here. The point was 1, 2. So here y sub 1 is actually positive 2. So that is y minus 2 is equal to, now first I am going to use the value of m as positive 2. So I am using m times, which is positive 2, times x minus x sub 1, which is positive 1. So that is one of the equations. If we simplify this, what we get? Well, it would be y minus 2 is equal to 2 times x minus 2, and from here we can say, well, then 2 times x minus y equals 0. So that is the first equation. That is the equation of our first new line. And let's try to come up with the equation of the second new line. Well, for the second one we can say it would be y minus y sub 1, which is 2, is equal to the slope. This time I am going to use the negative 1/2, so that would be negative 1/2 times x minus x sub 1, and from here if we multiply both sides by 2, then we get 2 times y minus 2, and then on the right hand side it would be negative 1 times x minus 1, which is actually equal to negative x and positive 1. And then if we bring everything to the left hand side, we are going to get 2 times y minus 4 plus x minus 1 is equal to 0, and from here we can say, well, then definitely x plus 2y minus 5 is equal to 0, and that is the equation of our other new line. Also, another thing I wanted to highlight is that the two slopes that we found, the two values of m, right? One value was 2 and the other value was negative 1/2. If we multiply them, we are actually going to get a negative 1. That means those two lines are perpendicular to each other, and that was the expected result, because we know that our two new lines are always perpendicular to each other. When the product of the slopes of two straight lines is equal to negative 1, we know that the straight lines are perpendicular to each other. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. And in our example, obviously that was the expected result. So our result seems to be correct, and we have the equations of our two new lines. This brings us to the end of this video. Hope everything made sense. Thank you for watching. See you in the next video.